Hi everybody, this is Eugene O'Loughlin, lecturer in computing at the National College of Ireland, and welcome to a series of videos on problem solving techniques. In this episode number 2, we're going to take a look at value analysis. First of all, a definition of what value analysis is, and I'm taking this from the Canadian Society of Value Analysis. Value analysis is defined as a systematic and function-based approach to improving the value of products, projects, or processes. And it was first proposed by, picture in the man here is Lawrence G. Miles, when he was working for General Electric on aircraft components. So value analysis is mostly about function. What does it do? Value analysis analyzes the functionality of a product. It states an estimated cost for each function, and we use it to demonstrate a function as compared with that of a competitor's. That is a very important component of value analysis. This technique therefore forces an assessment of the manufacturing processes, parts and materials, and design features of a product. So I suppose the most important thing about value analysis is that it's about value. All commercial activities are performed with the objective of providing value of some kind, where the value is a combination of the benefits gained from the activity and the cost of achieving these benefits. So quite simply, in this formula that I'm using here, value equal to worth divided by cost means that a value of 1 or over represents good value, a value of 1 of less than 1 represents bad value. So when do we want to use value analysis? Well, we want to use it to identify needed product improvements. We may have a product or a service indeed that is in need of improvement, something that could work better than it should, or maybe we need to save some money, so we may use value analysis to lower product costs. We can also use value analysis to prioritize product redesign activities. Many products are made up of several components, and value analysis can help us to identify which components need to be redesigned or can be redesigned. And finally, value analysis can be used to determine the real value of each component. So let's take a look at a simple example of a pencil that we are all familiar with. A pencil can be divided up into 5 parts like I've done so here. At the tip of the pencil, of course, we have the graphite, whose function is to make marks. We then have the wooden case, and the function of the wooden case is to hold the graphite. Next we have the eraser at the top of the pencil, and its function is to remove marks. We have a metal band, and its function is to hold the eraser. And the final part is the paint, and its function is to protect the pencil and perhaps improve its appearance or carry a logo or a product name. So the primary concern is to determine functions that have a high cost associated with them. So for example here, let's say the metal band was the function here that had the highest cost associated with it. We would target that for redesign, perhaps substituting a cheaper metal that performs the same job to the same quality, or sourcing metal bands from a lower cost supplier, or redesigning it so that it doesn't cost as much. So the fundamental concept underlying value analysis then is functions. Ask yourself, what does an object do rather than how is an object made? Now let's take a look at a more complicated example. Ralph Waldo Emerson said, if you build a better mousetrap, people will beat a path to your door. So I'm going to use the mousetrap here to illustrate in more detail how value analysis can be used. And in our simple mousetrap here, we have once again 5 main components. We have the locking bar, we have the bait pedal, we have the spring, we have the hammer, and we have the platform which everything is held on. And each of these components will have several functions. So let's examine each component and see what functions are associated with each one. In my table here, I have my components, 5 components listed down along the left hand side. And you can see in the next column I have several functions associated with each component. So for example, the platform has 4 functions: support other parts, resist overturning, hold the trap, and display the manufacturer's name. And we look for each component and list the functions of each component, and you can see them here on the table. In my third column then, I compare my functions with that of a competitor, and this can simply be done by going out and buying a competitor's design and comparing your functions with theirs. So for example, we can see once again, looking at the platform component, the function support other parts, well, our design is the same as that of a competitor's. the resist overturning function, our design, or the competitor's design, is worse than ours. Whole trap, ours is the same. And we can look down through the list here where we can see where our competitor's design is the same, better, or worse than ours. In a couple of instances there, you can see that there's not an applicable. If there's nothing in the competitor's design that can be compared, just leave it as NA. In the next column, we look at the importance to customers. And we can do this by doing a customer survey, setting up a customer focus group, or interviewing some key customers to find out the importance of each of the functions that we have identified, how important they are to each customer. So for example, the platform whose functions support other parts, well, that's of low importance to customer. We can see resist overturning is of medium importance, and if we look down the list, we can see for the bait pedal component, the function hold bait, well, that's a very high importance to a customer. So for each function then, we're able to say whether it is of low, medium, or high importance to our customers. In the next column then, we have money. We list the cost in euro of each function as a proportion of overall cost. So for example, the platform component, we've allocated a cost of 12 cents for support other parts. We've allocated a cost of 7 cents for the function resist overturning. And so on down along. For each function, we allocate a cost as accurately as possible for each function. And the next column then, we just simply convert that into percentages. And what we're looking for is the functions with the highest percentage. So straight away we can see in the middle of our chart here, for the component spring, which has only got one function, our competitor's design is the same, it's of medium importance to customers, and we can see that it accounts for 35 cents overall cost, which represents 17.5% of the overall cost. This is our highest cost. We list that then as number one. I've highlighted it here in grey. Number one, priority for redesign. We look at the second highest, which is 11.5% of cost, and that represents the function hold bait, part of the bait pedal component. We also look down further, and we go down as far as the third, which is easy to set, which represents 10% of our overall cost. And we prioritize then, based on proportion or percentage of each function, we prioritize and list them from 1 to 17. There are 17 functions listed here, priority for redesign. So I've mentioned previously we are going to look at those components, the function of components which have the highest cost associated with them. Therefore, if we can redesign those functions, maybe make them better, make them simpler, introduce a cheaper part, that will give us the best value. If we can reduce that proportion, it will increase the value of our mousetrap. If we take a look at item number 17, which is the lowest priority for redesign, that's prevent escape, part of the hammer component, we can see it's of high importance to customers, but we can also see that it is only represented by 1% of the overall cost. So redesigning this particular component will have a minimal effect on the overall cost of our value of our mousetrap. Therefore, it will not give us much better value. We target those ones with the highest cost associated with them. So what do you do next? Well, as there's a lot of data concerned, recheck your data and make sure you've got the most accurate cost that you can possibly have. Value analysis doesn't take into account the cost of redesigning each function or how difficult it is to design each function, so you'd have to look at that as well. It could well be that our number one priority for the redesign could have a very high cost associated with it, money that you don't have, and it may also be something that's very difficult. If that's the case, look at priority number 2 or 3 and so on down. Whatever the case, you'll need to do a cost-benefit analysis for redesigning of a particular function, and that's a problem-solving technique which we'll be looking at in a later video. You can learn about value analysis and other problem-solving techniques from my new book, An Introduction to Business Systems Analysis, which is only available online at online stores like Amazon. Thank you very much for your attention. I hope you found this video useful.